This is the video lesson for uniform circular motion. The learning target for this lesson is I am learning to examine and describe motion in 2 dimensions using examples in uniform circular motion. The success criteria for this lesson are I can explain the concepts of velocity, acceleration, and centripetal acceleration. I can describe the relationship between the radius of a circular path and the velocity and acceleration of an object moving in a circle, and I can define centripetal force and centripetal acceleration using equations. So what's happening when something moves in a circle? To start off, it's called circular motion. When something's moving with a constant velocity, it's called uniform circular motion. So there's a force that's causing the object to turn toward the center, and that's called the centripetal force. So what about the velocity in uniform circular motion? So velocity is a vector, so it has both a magnitude and a direction. And the magnitude is uniform in uniform circular motion, meaning that the speed of the object going around the circle or going around a circular form doesn't change. But the direction of the velocity is constantly changing because it's following that circular path. So as an object moves around a circular path, the direction of the velocity vector is always changing. So you can imagine we've got a circle and the velocity vector is always pointing in a different direction. So what about acceleration in uniform circular motion? So acceleration is also a vector. So again, it has magnitude as well as direction. The magnitude of the acceleration in uniform circular motion is also constant. So it's also uniform. The amount of acceleration doesn't change. The direction of the acceleration vector always points into the center of the circular path. So if you are exhibiting circular motion, so if an object is going around in a circle, the vector for the acceleration is pointing into the center of that circle always. If you're talking about circular motion of a car going around a curve, the acceleration vector is pointing into the center of what, if you extended that curve that a car was going around into an entire circle, the acceleration vector would be pointing into the center of that circle. And we call the acceleration uniform, we call it centripetal acceleration. So whenever you have a circular motion, regardless of whether it's uniform circular motion or just circular motion in general, we call the acceleration centripetal acceleration. So let's look at the equation for centripetal acceleration. So we have a sub c is equal to v squared over r. So a sub c equal to centripetal acceleration. Then we have v is equal to the linear velocity, which is also called the tangential velocity. So if we have an object moving in a circle, the velocity that we're talking about here is this velocity that's going off at a straight line. So wherever the object is on the circle, this velocity here, this is the velocity that we're talking about. So we call it the tangential velocity or the linear velocity because if you let go of whatever force it is that's holding the object moving in the circle, if that force disappeared, the velocity, the object would fly off in this direction of the tangential velocity. And then we have r, which is the radius of the circular path. So this distance here would be r. All right, so now we're going to look at the equation for centripetal force. So we have Newton's second law here. So this is Newton's second law, F equals ma. And we have our acceleration from the last slide. So our centripetal acceleration is equal to v squared over r. And we're going to replace the acceleration in Newton's second law with this acceleration. And we end up with our centripetal force. So F sub c, which is our centripetal force, is equal to mass times v squared over r. So this is our centripetal force. So force is equal to mass times v squared over r. All right, everybody, keep asking questions. It's how you learn new things.